Okay, so section 7.1 talks about pictographs, bar graphs, and line graphs, okay? So let's go through these here and see if we can't figure this out. Let's see, the directions here say the following pictograph shows the top eight most spoken or primary languages. Use the pictograph to answer the following questions. Okay, so as I start to look at this picture, it looks like every little person represents 50 million speakers. So the first question here says, approximate the number of people who primarily speak Hindi. Okay, so Hindi is right here. And we have 1, 2, 3, 4, 5. There's 5 people. And if each person represents 50 million, 5 times 50 would be 250 million speakers who speak Hindi. Okay. Now let's take a look at the next question. The second question says, how many more people speak English than Hindi? Okay, so we already knew what Hindi was. Let me just get rid of that circle. Okay. So here's English and here's Hindi, right? Those two right there. We have 1.5 more. So we're going to go 1.5, 1.5, right? That's what a half means, times 50. And again, I'm going to use my calculator here. Turn this thing on. 1.5 times 50 is going to give me 75. So that would be 75. Oops. Let's get the pen working again. Okay. So that would be 75 million, right? Okay. Alrighty, the next question says, how many people speak Spanish? Okay, so here's my Spanish. I'm going to count the folks that speak Spanish. 1, 2, 3, 5, 6, 7, 8. So we have 8 times 50 should give me 400. So that's 400 million. Okay. Let's see. The next question says, approximate how many more people speak Spanish than Arabic. So we had 8 folks here. Under Arabic, I have 1, 2, 3, 4.5. There's 4.5 here, so 8 minus 4.5 is 3.5. I'm just going to shift this down a little bit, okay? So 3.5 times 50. Again, I'll use my calculator for that, guys, just so you can see what I'm doing. 3.5 times 50 is 175. So 175 million folks, right? All right. So I'm hoping pictographs seem to make sense. Let's take a look at the next one here. It says the following pictograph shows the number of approximate solar system exploration missions by various countries or space consortia from 1957 to the present day. Okay, so it looks like each little capsule represents 8 solar system exploration missions. The first question says, approximate the number of solar system exploration missions undertaken by the U.S. Well, right here, so let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So again, we're going to take 17 times 8. I'm going to use my calculator again. 17 times 8. Oops. Times 8 is 136. So we took 136. And the next question says, how many more have been taken by the U.S. than by Russia? Well, we have 1.5 more, right? So 1.5 times 8 should give me 12. Okay, what about the Europeans? So the Europeans have 1.5. So again, we already said that 1.5 times 8 was 12. And then, let's see, approximate the number of solar system exploration missions undertaken by the European and Japan. So European was 12, Japan is another 8. So that should give us a total of 20, right? Because each one is one, each little capsule is 8. Alrighty. So now let's talk a little bit about bar graphs. Okay, so it says the following bar graph shows the number of endangered species in the United States in 2013. Use this graph to answer the questions. Okay, so it says approximate the number of endangered species that are clams. Okay, so here's clams. Okay, so that's 20, 40, 60, that's 80. So this is going to be 70 right there in the middle. So it looks like it's about, what, 75 is what I would say. All right, so 75. Which category has the most endangered species? So which is the biggest bar? It looks like the fishes. Okay, let's see. Approximate the number of endangered species that are amphibians. So amphibians is right here. So let's see, if that's 20, I don't know. Again, approximate, guys, means let's take a good guess. I'm going to guess about 18. You could say 19, right? Don't guess 4, right? Because it's obviously not 4. But approximate means we're going to take a guess and a good guess. Which one has the fewest? So which is the smallest bar? So if I just start looking at small bars, like that's a small bar, that's a small bar, that's a small bar, right? Those look pretty small. So then I'm going to say, well, this one looks a little bigger, so I know it's not that one. So it's probably going to be between the reptiles and the arachnids. And if I look, this bar looks like it's a little bit lower than that one. So I would say the arachnids, right? The spiders. Ooh. Okay. Scary. Okay. If you're scared of spiders, I know I am. All right. So, taking a look here, the next piece we have, guys, I'm hoping these problems are making sense. They should be relatively easy breezy cover girl. Okay, so it talks about reading and constructing histograms. So it says, suppose that the test scores of 36 students are summarized in the table below. Okay, so let's take a look here. They're giving me ranges. Some people scored between a 40 and a 49. Some people scored between a 50 and a 59, 60 and 69, so on and so forth, right? These are the number of students. So we had one person who made somewhere between a 40 and a 49, right? We had 10 people who made between a 70 and a 79, so on and so forth. If I were to say, well, what's the total? I could add those numbers up, right? But if I also pay attention, it tells me that the total should be 36 because it says there's 36 students. So this here is what we call a frequency table. Frequency means how many times did it happen. So how many times did somebody score between a 70 and 79? 10 times, right? That kind of thing. Now, the other way we can have this is in what we call a histogram. A histogram looks very much like a bar graph, okay? So here's our histogram. If you notice, these are the same test scores, 40 to 49, 50 to 59, so on and so forth, okay? So the first thing I'm going to do is I'm going to label these, okay? So those are 2, 4, 6, 8, 10. This here means that there was one person who scored between a 40 and a 49. If it's between 2 and 4, there's 3 people here, 2 people here, 10 folks there, 12 folks here, and 8 right there. Let me fix that. Oops. Let me fix that 12 so it looks a little bit better. 1, 2. There we go. Okay, remember, I also know that my total was 36. So the first question here says, how many people made between a 50 and a 59? Well, here's 50 and 59. We had a total of 3. How many students earned grades of 70 or higher? So 70 or higher would be actually those 3 bars together. So I'm going to add 10 and 12 and 8. So that should give me a total of 30. Okay. How many students earned grades of 69 or less? 69 or less would be these right here. So I'm going to add 1 and 3 and 2. That's going to give me 6. What was the total number of students? We said 36. Okay. Now, question number 5 says, what percent of students earn grades 70 or higher? Remember, percent means out of the whole. So there's a whole of 36 students. The ones that earned a 70 or higher was 30 out of the 36. Okay. Now, guys, I'm going to go ahead and use my calculator here. So let me take 30 divided by 36. And I'm going to multiply it by 100 so I can move my decimal place 2 spaces to the right. Now, again, in my math lab, it'll ask me round to a particular place value. I'm going to go ahead and just round to the nearest tenth. So this here would be 83.3, right? 10th position means we want to have exactly one number behind our decimal point. Okay. Number 6 says, what percent of students had grades of 69 or less? Well, remember, again, we know we had a total of 36 students. 6 of them had a grade of 69 or less. So I'll do the same thing here. 6 divided by 36. Let's multiply it by 100 to move our decimal 2 spaces over. So again, I'm going to round to the nearest tenth. So 16 point, it wouldn't be 0.6, it would be 0.7 because of the number to the right of it, right? So here I would say 16.7%, right? And 83.3%. Okay. So let me scroll down. Let's go ahead and try the next one. So here's another histogram. And let's see. So first thing I'm going to do, I'm going to label it just like we did the other ones. Okay, so look, this should be easy for me to label. That's 1, that's 3, that's 11, that's 7, and that's 8. Okay, so this is obviously telling me the number of days, and we have temperature ranges here. So let's look for number 1, the total number of days. So I'm going to add those numbers together. I'm going to add 1 and 3 and 11 and 7 and 8. So 1 plus 3 plus 11 plus 7 plus 8. Oops, that's not an 11. Plus 7 plus 8 is 30. Okay, 30 days. So about a month, right? Okay. So now, let's start answering our questions. How many days was the temperature between 91 and 93? Right there, 7 days. How many days had temperatures of 85 degrees or higher? 85 degrees or higher are going to be all those days. So we're going to add 3 plus 11 plus 7 plus 8. Guys, if you notice, we added all the numbers except for that one. So we had a total number of 30 days, and now we'd have 29. Okay. Alrighty, so the next question says, how many days was the temperature 90 degrees or cooler? 90 degrees or cooler would be those right there. So if I add up 1 plus 3 plus 11, I should get 15. Okay. All right, which temperature readings had the most days? Well, this is the biggest bar, but those temperature readings are between 88 and 90, right? That's the one that has the most days because it has 11. All right, let me scroll just a little bit here. Which temperature had the least days? Well, the temperatures of 82 to 84. How many days were temperatures recorded? We said this was a total of 30 days. Okay. I'm going to scroll down a little bit. What percent of the days had 85 degrees or higher? So again, we know the total was 30 days. 85 degrees or higher was 29, right? Again, I'll use my calculator one more time. Let's move this over here. 29 out of the 30. And multiply it by 100. And again, I'll still round to the nearest tenth. So I'm going to say 96.7%. How many days had temperatures of 90 degrees or less? Again, we had a total of 30 days. The ones that had 90 degrees or cooler was 15. If you take 15 and divide it by 30, it's going to give you 0.5 or 0.50. Move the decimal 2 spaces over, and it is 50%. Okay. So let me keep scrolling here. Okay, so now we have a line graph. Okay, so it says, the following line graph shows the average daily temperature for each month in Omaha, Nebraska. Use this graph to answer the questions below. So I want you to notice here, these are the months: January, February, March, April, May, June, July, August, September, October, November, December, right? Okay. During what month is the average daily temperature the highest? That would be July. From what month through July through December? So they're asking me to look at these months here, July through December. Is the average daily temperature about 65 degrees? So I'm going to scroll this way, 65 degrees, but this is the one we want to use. So that would be September. Okay. During what months is the average daily temperature less than 30 degrees? Okay, less than 30 degrees. So less than 30 degrees would be anything below that bar. So I would say January and February for sure, and December. So January, February, and December, right? Okay, I'll scroll a little more. When is the temperature the lowest? So the lowest looks like it's going to be January, right? Okay. Let's see. During what month is the average daily temperature 25 degrees? So again, if I come back here, here's 25 degrees. That looks like February, right? And let's see, we got another question. During what months is the average daily temperature greater than 70? Okay, so we're going to go greater than 70. So let's think about what greater than 70 really means, okay? So greater than 70. So here's my 70. Looking at this line right here. I'm looking for the months that are higher than that. So this one here, this one here, this one here. So June, July, and August. So we would say June, July, and August, right? Alrighty. Guys, I'm going to go ahead and do this all in one video because this section is pretty short here. So reading circle graphs. Okay, so it says the ratio of adults preferring basketball to total adults. So number one, what we need to do is find the total. So again, I'm going to take my calculator. I'm going to move this over here. Let's clear that out. Let's just start adding them up. So I'm going to go, I'll start from basketball and I'll just go around this way. So we're going to go 20 plus 37 plus 4 plus 3 plus 8 plus 13 plus 15. That's all of them? Yep, we got 100 folks. Okay, so total is 100 folks. Now it says find the ratio. Ratio just means, guys, that we're going to write a fraction. Basketball to total adults. So basketball is 20 over 100. I'm going to divide them both by 20, 1/5. Okay? Because it tells me to simplify. Write the ratio of adults preferring golf to total adults. So golf is going to be 8 out of 100. I'm going to divide them both by 4. 4 goes into 8 twice. 4 goes into 100 25 times. And we're reduced. Okay. Alrighty. So now we have voters. Voters by region. The following graph shows the percent of visitors, not voters. The following graph shows the percent of visitors to the United States in 2012 from various regions. Using the circle graph shown, determine the percent of visitors who came to the United States from both Mexico and Canada. So Mexico, we have 21.3%. Canada, we have 34.1%. If we add those numbers together, we should come up with 55.4%, right? Okay. Let's see. Now we want to know the percent of visitors that came from Europe, Asia, and South America. Okay, so South America is 9.5, Asia is 12.5, and Europe is going to be 18.7. Again, I'm just going to take my calculator. I'm going to add those numbers up together. So 9.5 plus 12.5 plus 18.7 is going to give me 40.7. So 40.7%. Okay. And let's see, that was 7.2. Okay.